Okay, so for the first problem here, hopefully you wrote this down, hopefully you've written all of them down in your notebook, but for the first one, so I went ahead and I did this one, and this problem, there are a lot of possibilities as you can see here, right? Lots of possible options because of this negative 30. So with all these possibilities, you just kind of want to start small and then avoid any fractions out would be my best recommendation. So I would start with 1, a -1, 2, a -2, and just kind of keep going up the line. So what you're going to find is that when you plug in a 2 as your possible 0, you do get no remainder. All right. Now this is good because now you know what your new factor is, right? You know, I'm going to change the color here to red, that because 2 is a 0, that means one of your factors is x minus 2. And because these are your values when you have a remainder of 0, these values become the coefficients of your new polynomial. And again, this new polynomial, because you factored out an x, it becomes 1 degree smaller than your original polynomial, right? You were at x to the third power, but now you factored out an x, so you've got to be at x to the second power. And you just write these as in descending order in standard form. So we've got the 2, the 13, and the 15 there. And now that I've got this trinomial, I can actually factor this because 2 times 15 is 30, and then I'm looking for two numbers that multiply to be 30, but add up to be 15. So you can go through that whole process. Once you do that, you'll find that you'll get these two factors, and then you can just find your answers after that. All right, so we get 3 rational solutions. And if I were to graph this on Desmos, I would find that those are the 3 rational solutions. For this one, I would start with grouping. All right, this you can use the grouping method because you have common factors. So if I take out x to the cube, x cubed from the first pair and -8 from the second pair, I end up with a common factor of x plus 1. So the x plus 1 comes out in front, leaving me with x cubed minus 8. Well, that's just a difference of cubes, right? X cubed minus 8 is a difference of cubes. So I can take this x cubed minus 8 and write it as a binomial times a trinomial. Keep in mind, same opposite, always positive. So once you've got the same opposite, always positive, and you factored this, you'll now have to use the quadratic formula on this piece here, and that will give you 2 possible imaginary solutions. So looking at everything, the answer of -1 comes from your first factor, the answer of 2 comes from your second factor, and the answers of the imaginary answers come from your quadratic right here that you have to use the formula for. And then at the end here, all right, we have something to the 4th power. So this is the highest degree we've worked with so far. But if I try that rational 0 test, my constant is 2, so those factors are plus or minus 2, plus or minus 1. And then if I look at my coefficient of 1, that means that plus or minus 1 is just my leading coefficient. So when I divide these, the only possibility for rational zeros occur at +1, -1, +2, or -2. So I'm just going to test out a 1 to start with, and we actually get lucky because when I plug in a 1 here for my possible 0, we do get a remainder of 0, which is great. So what that means is that because 1 was a 0, x plus 1 is going to be a factor. And then you can just, again, take the 1 is your coefficient of your x cubed. -1 is the coefficient of your x squared. 2 is the coefficient of your x, and -2 is the coefficient of your constant term. All right, so that's how that works. So from here, you could actually factor this by grouping, right? We could take out an x squared from the first term, and a 2 from the first pair of terms, and a 2 from the second pair of terms. So you could factor this by grouping, which would be the smart way to do this. But I want to show you that even if you forget to use these methods, you can still continue to use synthetic division to find the other answers. All right. So I'm going to do it again where I have to use synthetic division one more time, even though I could use grouping. So what I do is I'm looking at my coefficients, right? A 1, a -1, a 2, and a -2. So those are my new coefficients that I put in this top row, because now I'm trying to figure out how can I take this polynomial that we have up here in the red and reduce that even further. So notice how the 1 goes here, the -1 goes here, the 2 goes here, and the -2 goes here. So I'm now taking this polynomial and I'm looking for the possible zeros. So I'm looking at this polynomial. Well, if I've got a 2 here, that gives me these possible values in the numerator. And if I've got a 1 as my leading coefficient, that's the possible value here. So again, for this problem, I know that my possible zeros are plus or minus 1 and plus or minus 2. So again, I'm going to start with the smaller number. I'm going to test out a 1. And when I test out a 1, it actually also works out to be 0, which is great. So when I test out the 1 and we get a remainder of 0, that means that this is going to be my remaining quadratic, right? 1x squared, 0 x's, and 2 is my constant. So where we're at so far, if you're keeping track, is we have already taken out a 1, and that left me with the factor x plus 1. Sorry, x minus 1. Go ahead and change that. Make sure you fix that. It should be x minus 1. And then because I had another factor of 1, that means that if I had another 0 of 1, which is right here, that means that my factor is x minus 1. So far we've taken out an x minus 1 right there. We took out another x minus 1 right there. So now I just have this trinomial remaining. And I don't really need the 0x there. I can just rewrite this as x squared plus 2. So with the x squared plus 2, I can set it equal to 0 and then solve. And when I solve it, we get plus or minus I square root 2 after I make that solve. So when I look at my final answers, let's keep track of what we've got. One of our answers is going to be -1. Now this -1 actually has a multiplicity of 2 because remember we took it out twice. We took out the 1 here and we took it out here. So we took it out twice. It's got a multiplicity of 2. So what that means is that it's going to bounce. Sorry, I messed up my signs again. This should be a positive 1. Right, we said we took out a 1 here, right? So 1 is my 0, not -1. My mistake. So 1 is going to be my 0. And again, you could graph this on Desmos and you could double check your work just to make sure you're understanding all this. But that means because it appears twice, it's going to bounce at that positive 1. All right, so at that 1, it's going to make a bounce. And then we also get these two imaginary zeros, and these imaginary zeros are occurring at I square root 2 and -I square root 2. All right, so that's how this kind of works. You could have a problem where you do get that kind of multiplicity. And so even though it looks like I only have 3 solutions, we do actually have 4, and we need 4, right? Because fundamental theorem of algebra says that because my degree here is 4, I definitely have to have 4 terms. 4 zeros. So we've got 1, 2, 3, 4. So we're all ready to go. All right, so those are the notes. I have a Delta math assignment for you to work on, which kind of goes through these things. If you still feel stuck, go ahead and click on show solution. You can work through how they solve it, which is just how I solve it, but they use some good colors and they use some good explanations in there, which might help you out. So give it a shot. Some of this stuff is also a review from the previous class, so you can try those as well. If you have any questions, I'll be able to help out in the morning, so you can come in for extra questions if you have those. All right, so sorry about all the small mistakes I was making there. Hopefully I didn't confuse you at all, but again, if you have questions,